This is a video for the zyBooks 5.1 for CS 121. 5.1 is about loops, and actually the entire chapter is about loops, chapter 5. A general idea of a loop is anytime you want to repeat things in a program or in life, like here they're talking about how you keep a baby from crying. My parents used to talk about my brother needing to be taken out and driven around before he would go to sleep. But where you've seen it is when you're playing video games, you often end up with one of the last screens shown being game over, play again, yes or no. If you hit yes, then it starts the game again. So there's another place that you're going to see loops. We've computed averages of numbers in a list by doing the sum of the list divided by the length of the list. But you could also compute an average by looping through and getting a new number every time from a user. So you sum them up as the user gives you a new one. You just keep adding it. So here I could have put sum plus equals value. So the value is what you're getting from the user. And then once you're done, you would also need a counter here to determine how many times you got a number from the user, and you divide by that counter. Loops can be very helpful in determining certain kinds of values in a list. Here we want to find how many negative values are in the list. So as we start this, that is one negative value. The next value is not negative. The next one is not. The next one is. The next one is not. The next one is not. And the next one is not. So I had two negative values in my list. I could also find the maximum value. Now if I know I have no maximum value that's negative, I could start with a maximum value of -1 and update it if I find something larger. So you might have a dummy variable called max, start it with -1, and if I find something bigger, then I'll set it to that value. So I started with -1, now I have 94, so I'll store that value. Do the next value, I won't store that one. 98 is bigger, so I'll store that value. This is exactly what your program is going to do, but you have to figure out the code to make it do this without actually looking at each value. All right, and that would be my store value. We're going to look at several different kinds of loops here. The first one is the while loop. So you'll have while some expression, and this will be a Boolean expression in here. You'll go through these steps. Notice that it's indented, and then any statements afterwards would have to be not indented, so it knows that you're out of that while. The participation activity in 5.2.1 has a pretty typical while loop, and it's a lot like the ones that are here. Play again, yes, no. So basically you set up a dummy variable called true, false, or yes, no, or something. We'll look at the program in just a second to see where that is. And when the user says no, you pop out of the game, and the game is over. As long as it's yes, you keep playing the game. So in this loop, we have a current powers 2. The user character is y. So they put in yes. So we're going to go through the game, so to speak. And here they ask for the user character input again. So the input would be a yes for the second time. So it goes through the loop again. And for the third time it says no, so it prints done. So yes, yes, no, we print this output. Now notice that when it goes in the loop the first time, that's a yes, it goes through the loop. It asks for user input. That's the first yes that the user gives. The second yes the user gives, and then the no. So it actually went through this loop 3 times until it got an N from the user. Instead of a while loop with the yes required to continue the loop, we could have what's called a sentinel value. So sentinel is another name for soldier, so it's waiting and watching for a particular value. So in this case, the user value is not equal to Q. So that means the while loop is going to be done until the user enters Q. So you'll go over and over again. It'll ask you for a character. It'll draw the picture that it's looking for here. And over again, it'll keep running the loop until you finally enter Q. Now notice down here at user input, it asks you for any character. It actually asks for a string here, so you're getting in a string, and then you're going to take just the first character in the string. User input 0 would be the first character in the string, so I could put the whole alphabet or my name or anything, and it's just going to take the first character. And if that character is Q, it won't run this again, and you'll print goodbye. Any other character for the first character here, it'll run the whole loop again. For all the loops we're going to discuss in Python, or any program at all, it's easy to get into what's called an infinite loop. And it's one that's going to keep executing because there's no way to get out of it. Or in other words, it executes because the loop's expression is always true. So in this case, while has an expression, this Boolean expression here. If it's true that, if it's never going to be true that the year considered if it's never going to be false that the year considered is greater than or equal to user year, then this is going to continue working through this loop, and that would be an infinite loop. The 5.2.2 challenge activity is only wanting the Boolean expression that needs to go here for non-negative number. So you want the loop to run as long as the user number is not negative. Cryptographers like to encrypt things using really large prime numbers because it's difficult to find greatest common divisors for large prime numbers. So if you know enough about how someone's encrypted some, you'd be able to hack the code and actually do some damage, possibly. So here they're showing an example of a greatest common divisor, and it seems like a fairly simple mathematical concept, but when you're talking really large numbers with programming, this isn't necessarily an easy process. But for this case, we're looking at fairly simple ones. If I run this code, you can see it gives me a positive integer and a second one with 20 and 15. The GCD is 5. So it looks like it's working. What if I put in here 2001, 157, 6, 156. Now run this. It should take it a little bit longer to run, but I know both of these numbers are divisible by 3, so I should find something. And actually, the greatest common divisor is 3. So I could put this in my calculator and check it and see if it's right, working with parts of the calculator, but it's pretty much doing the same algorithm on the calculator when I'm looking. There are other ways to find the GCD in programming, but this is one way using Euclid's algorithm. So we're going to take these two numbers, and if number A is not equal to number B, and if number A is bigger, we're going to subtract off number B from number A. And if number B is bigger, then we'll subtract off number A. So this subtraction algorithm is going to take us down to the point where we're only left with the greatest common divisor by taking off multiples of what is the greatest common divisor. This conversation example exhibits a couple of new concepts for us. One of them is the random number, so you'll need to import random, and you'll have random equals rand integer 0 to 2. So it's the beginning random integer you're going to use and the end that it's going to use. So you have the 0, 1, or 2 as possibilities. So that's import random and random.randomInt from the beginning to the end. The other concept is if we add another see you later here. So this was originally if you say goodbye, you're going to get out of the loop. So here, if the statement that I put in for the user is you can type goodbye or see you later at any time to quit. Well, if I negate this, which is user text is not equal to goodbye, the original one they had in here, then I'll go through the loop. But if I negate this, I also have to negate the or, and the negation of the or is an and. So this logic can be very tricky. So if you can type goodbye or see you later. So if you don't type goodbye and you don't type see you later is the logical opposite of if you type goodbye or see you later. So be careful with your logic. Also note that this program is using an if-elif structure to use a random number, these are 0, 1, and 2, to print out a random response for the user. 5.3.3 is computing an average with a sentinel value. So we have a sum of the values divided by the number of values is going to give us our average. So we need both of those numbers. If we were using a list, we'd already have the sum and the length as parameters that we get from the list itself. But here we will ask the user for a value. If it's greater than 0, because we want positive integers, then we'll add it to our current sum, and we start with a sum of 0. And we'll also increment our number of values. So the first time through this loop we have 1, and then we'll ask the user for another number. If they give us a value that's greater than 1, we go through the loop, greater than 0, we'll go through the loop again. We'll do that until they give us something that is 0 or less, and then it'll compute the average. Notice the format here. Average is no decimals with an F. We want value sum divided by num values, which is exactly what we're thinking for the average there. The 5.3.1 challenge activity is showing you how you would get a minimum from a list of numbers that users input. So you're going to have the minimum value as the first entered value, and then you're going to switch it off until they give you the sentinel. And here, anything they give you 0 or below is going to be a sentinel value. And when you're done with the program, you've gone through the loop as many times as the user entered something bigger than 0, but you should have a minimum value when you get done. You could see really easily how you could change this just a little bit if you wanted a maximum value. In 5.3.2 challenge activity, they just want you to put what should be the Boolean expression to make sure that you get yeses and nos correctly out of this program. For the 5.3.3 challenge activity, we want to be given a positive integer, and they've given us a variable to use, and write a while loop that prints then doubles the variable each iteration. And we want to print values that are less than or equal to 100. So the first thing I notice is that it says right here that it must be greater than or equal to 1. So if you don't want to print it in anything, or you want to check this, it doesn't say to, but I'm going to. If num insects is less than 1, then I'm going to rename num insects to be 101. So I want to make sure that the code that the input that the user gives me is actually valid. So this is checking validity here. And it might fuss at me for doing it, but I want to think about checking validity anytime. Checking for valid input. So I always want to be conscious of the valid input. So while the num insects is less than or equal to 100, the first thing I'll do is print num insects. And then I'll double it. So num insects times equals 2. So I ran this and I ended up with my output going to a new line, and that's not what they wanted. They wanted it to have some spaces in between. So how do I fix that? So what I need is end equals a space. And that one ran correctly. Counting how many times you've gone through a while loop is a pretty standard programming practice. So in this particular one, there's a dummy variable, I is equal to 1. That's just going to add 1 every time I go through the loop. That's all it's doing, all the way up until the number n. So in this way, you're able to go 1 through n times through this loop. Now, there are a couple of things to note here. I could have been count. You could have called this anything. It's just a variable. And I plus equals 1, the compound operator, could have been used here instead of I equals I plus 1. The common error is to forget to increment, and if you don't increment, then you end up with an infinite loop. So the 5.4.1 program is calculating simple interest. So they're starting with a savings of $10,000. 0.05 is the interest rate. And here they want to print out what the interest rate is. So they're going to multiply by 100. So this will say 5% yearly interest. They want to have an input years from the user. And then they're going to start with the savings being the initial savings. So we're going to be adding some savings every year. So I equals 1 is where we're starting, and then we're going all the way up to the years. So the first year, I'm going to go through the loop, and then I'll add 2 through it, and it'll go all the way up to the number of years. So here, savings is being incremented. This could have been written as plus equals savings times interest rate. And we end up with the amount of interest that this user would have gotten with $10,000. Of course, you could play with this and see exactly what would happen at different interest rates, but this is just simple interest. It's not compounded, but one time a year. You could also count down instead of counting up, so 5, 4, 3, 2, 1, like a countdown. Or you could increment by a different amount. Maybe you want to count down by 2 or 15 or any other number, but you're incrementing by a different amount here. In this case, it's actually counting up. So if I wanted to increment over presidential election years, that's every 4 years to the present date, then I want to do some kind of increment in here. So it says 1792 to present day, and present day now is 2020, right, which is an election year. And then you want to print the election year too. So there's a little bit of code to add in here. 5.4.4 gives you an opportunity to try several different kinds of looping in here. 0 to 10,000 by 500s, so that means we'd be adding 500s. Negative 19, 19 by 1, so we're starting at negative 19 and going to 19. Multiples of 3 between 0 and 100. Well, 0 is a multiple of 3, so we can include that. Multiples of 3 would just be add 3. Keep adding 3 and printing out those multiples. The powers of 2 from 1 to 256 means that we'll be multiplying by 2. 2 times 2 times 2 times 2. And then you can come up with your own challenge too. The next thing we want to do is calculate a factorial. So n factorial will be n times n minus 1 times n minus 2. So if we had like 5, what they're suggesting here, that'd be 5 times 4 times 3 times 2 times 1. Or you could do 1 times 2 times 3 times 4 times 5. But they're suggesting decrementing here. So first I need to set I is equal to, and they give a suggestion. Use a loop that counts I, that counts from total minus 1. Total minus 1? So there's a suggestion for I. And we want to count I is actually greater than, for I greater than, now we could put 1 in here, or we could put 0, because when we multiply by 1, it's not going to change our outcome. So I'll put 1 in here. We want to set the total equal to total times I. So total times equals I, using the compound operator that I really like. And the decrement I, we want to do I minus equals 1. So if we run this, we get 120. And that should be right. So if I did 10 and run it, that should be 10 times 9 times 8 times 7 times 6 times 5, and so on, down to 1. The next little part says shorthand operators, and it said what I was just saying about using the shorter notation for I equals I plus 1. So decrementing and incrementing can be much shorter notation. As you work through the next few challenge operators, I recommend highly that you put an increment or decrement, in this case there's an increment, with a shorthand notation. So make sure you're using that notation wherever you can. It's fairly standard. Challenge activity 5.4.3 has more practice in actually doing a counting variable, and also how do you not go to the next line when you're printing. So remember that you have that end equals, and in this case we don't want any spaces in between the stars, we just want a bunch of asterisks. The next types of loops are for loops. So the typical structure is for some variable in some kind of container, and then we go through the loop. For a list like this, see the brackets, it says there's a list. So for name in Bill, Nicole, and John, and this could be any variable, whatever you want here, so you don't have to instantiate it. You're going to print hi, whoever, from the list, dot format name. So it goes straight to the list, Bill, Nicole, and John. Does it for every item in the list. In figure 5.5.1, they show a loop with a dictionary. So you have a key and a value, and it says for C in the channels, so that's for any of these keys. So for one of the keys in this dictionary, you want to print whatever the value is on channel value. So the first one is the key, C, and the second one is the value for that key. You can also do a for loop in a string. So they want to take this string, take me to the moon, and add a character in between. So for each character in take me to the moon, so it's going to go one at a time through the string, I'm going to do my string plus equals the character plus the underscore. So for each character in there, it's going to put the character and then the underscore all the way down to the end. So you can see the last character in this string was dot, the period, and then after that it also puts an underscore. Figure 5.5.3 is computing an average over a list. So given a list of daily revenues, it's adding the total up. Now we know we have a sum for the list, so this seems like a bit of an overkill, but it does show you how you can go through a list and actually add up everything there. You can also iterate backwards over the sequence. So all the ones we've done before have started at the beginning of the sequence and gone straight down. But if you use this reversed, that's a function, then it will print in the reverse order. Challenge activity 5.5.2 introduces a small little concept here. If you have a list of values set this way, you can do input.split, and it splits it into an actual list in Python. So if I printed out stock prices, I'd have the whole list printed out. Another way to do a for loop is with a range of values. So if you're given range of y, it's going to start with 0 and go all the way up to, but not including y. So it'll be 0, 1, and 2. So there's a way to think about this that you can get it right every single time you're looking at it. So if I have from 0, if I have just one value, it's going to start at 0 and go up all the way up to, but not including that 5. So less than 5 is what we're looking at. So the range is from 0 to less than 5 would be 0 to 4. 3 to 7 would be 3 to less than 7 is what I'm thinking. Less than 5 was the first one. 0 to less than 5, 3 to less than 7 would be 3, 4, 5, 6. So if I'm only given one, I start at 0 and I go less than that one. So it ends up with however many numbers I have there. If I'm given 2, I'm starting at that value all the way up to, but not including the second one. So less than the second one is what I would say. So this would be 3 to less than 7, 3 to 6. 10 to less than 13, 10 to 12. Now if I'm given just 2 numbers, I'm always counting up. But if I'm giving 3 numbers, I actually could be counting down. So I really need to look at a third parameter here, and it tells me that I'm going up by 1. This one tells me I'm going up by 2, so that'd be, in this case, it would be multiples of 2. So the first number is where I'm starting. The second number is going to be less than 5 if I'm counting up, but it's actually going to be greater than 0 if I'm counting down. So you have to look at the third parameter here to say whether you're going to say less than or greater than. So I start at the first number, less than the next number if I'm counting up. I start at the first number, greater than the second number if I'm counting down. So in 5.6.1, they're asking for an input number of years. So enter years, and that could be any number. So in range years, whatever they give me here, so maybe 5, that would be from 0 to less than 5. So we'd count from 0 to less than 5. Notice the variable here is I. So the incrementing variable should be I all the way through. The range does not show up again. It just gives me what my maximum or minimum will be and what I'm counting by. So now we have while and for loops. And for the most part in programming, you can use either one of these interchangeably. Sometimes it's better to use whiles, especially if you have like a yes-no setup for like to play again. We want to play until no is the answer. The nice thing about the for loop with the range is that this never gets into an infinite loop, while a while loop can get in an infinite loop if you don't remember to put your incrementer or decrementer. Just like the if, elif, else structure, in loops you can also have nested loops. So like you had nested ifs and elifs, you can have nested loops. So here's a nested loop example. So this nested loop example goes through the entire alphabet for both the first and the second character to come up with domains that are just 2-letter domain names. So ordinal here gives the number of the letter. So if I put letter 2 in here, which starts at A, if I put letter 2 in here, this is ordinal of 2 plus 1 is going to increment. So letter 2 is going to go up. And letter 1 is ordinal of letter 1 plus 1 increments. That will go up. So here are your incrementers for these. It's very strange code. You're going to see these characters and ordinals all over the Zybooks text, but I would never ask you this on a test. So your only places that you're being graded on working with these is within Zybooks. In 5.8.1, they want you to also put in, like on the last exercise, the AA, AB, AC on down. They want you to put it so that the second letter can actually be the numbers 0 through 9. So I'm basically going to repeat this while loop. But I don't want to increment the first letter until after I've done all of the numbers. So while I'm going to put I is in the range, and I want 0 to 9, so I'm going to put 9, actually 10, aren't I? So I can go 0 to 9, range 10. I want to print out these, and now instead of letter 2, I'm going to put I. And I don't need to update my letter 2. And instead of a while, I guess this is a for. For I in. And I'll run that and see what that does. So I get AG, all the way down to Z, and I have A 0 through 9. So that looks pretty good. 5.8.2 shows you a nested loop histogram example. So if you run this, we end up with, depicted graphically, 5 would be 5 stars and 10 would be 10 stars. So they want us to change it so that every asterisk prints 5 units. So if the user enters 40, print 8 asterisks. So here with 5, how would I get it to print 5 asterisks? Well, this would be the range equals num, so I basically need to increment by 5. So I'd start with the range is 0 to num, and then put comma by 5. We'll try that and see if that works. So I get 1 when I put in 5 and 10 when I put in, 2 of them when I put in 10. So if I put in 40, just put another one, I should end up with 8 stars. 1, 2, 3, 4, 5, 6, 7, 8. In 5.8.1, you'll be asking for 2 inputs, and they need to be positive integers. And the first one tells you how many times you're going to do, printing out the second number of asterisks. So in this case, I have 2 rows that I'm going to print out 3 asterisks each. This is going to require 2 for loops nested. For the next video, I'll start with the challenge activity 5.8.2 and work through some of this code.